Hello everyone. So today we're going to find the equation of the tangent line at theta equals pi over 2 for r equals 3 sine theta plus theta. So first and foremost, we have to find the slope of the tangent line. So we're going to use our equations r equals sine theta, y equals r sine theta, and x equals r cosine theta. And there's two ways of using those equations to find the slope of the tangent line. Like the first one basically comes out to using the box here. So what you see in the box on the numerator is r prime sine theta plus r cosine theta, and then on the denominator it's r prime cosine theta minus r sine theta. Basically the way it works is that you just plug in what r prime is and r into the spots where you see an r prime and an r, and yeah, r prime would be just the derivative of the 3 sine theta plus theta. That would go in there. And then you plug in what r is directly, 3 sine theta plus theta, and yeah, you would get an expression basically in terms of theta, and you plug in your pi over 2. Okay, so basically that's how that works. Now the only issue with that is that it's a formula and you got to remember stuff, and personally I'm not a fan of remembering formulas all that much, so if I can avoid it I will try to do so. And what you can try to do to avoid that is using the fact that, again, dy dx equals dy d theta over dx d theta. So let me kind of highlight method 2 here. Yeah, and this is the case because both y and x really depend on theta. Y equals r sine theta and x equals r cosine theta, but r is really in terms of sine. Yeah, and if I take y here and x and replace the r, you would get 3 sine theta plus theta times sine theta. And then for x, r cosine theta, replacing the r, you get 3 sine theta times cosine. And I'm going to take the derivative of each of those, and that's what you see here and then here. And then for my next step, all I did was I distributed the sine and then cosine. Okay, so we would be taking total the derivative of these two terms. And then what we're going to do here is we're going to go ahead and take the derivative of those two, sorry, I said terms, but it's expressions, of those two expressions. Okay, so again, the second method here basically works on the fact that you know that y is r sine, x is r cosine. You replace r with what it's given to you on both y and x, and you know you just might distribute, need to simplify, but then from at that point you need to take a derivative. Okay, and if you take the derivative of each of these, you're going to use a chain rule or a product rule, something along those lines. And so I won't go into that in detail, but I suggest maybe you pause the video and go through that, both the numerator and denominator separately, and then you get what you see. Let me box it in here with this color. You see that right there. That would be your derivative. But as I said, we're looking for a slope of a tangent line. So at a pi over 2, so what we're going to do is we're going to plug in pi over 2 into this whole expression right here, and then we get 1 over divided by quantity -3 minus pi over 2. Okay, so that is the slope of the tangent line. So once again, this is the second method. You could have used that first method, as I said earlier, and just plugged in pi over 2, and you would have gotten the same exact answer. Now, the problem says you have to find the equation, not just the slope. So we're going to find the equation using the point slope form of a line. So that's y minus y1 equals m times x minus x1. M here stands for the slope of a line, slope of the tangent line in this case. So we already have that. The issue is just finding y1 and x1, which isn't too bad. So whenever you're working with these problems, when you're finding equations of tangent lines with polar, the thing you have to remember is that y is equal to r sine, and then x is equal to r cosine. So if I want my y1, I'm going to be plugging theta equals pi over 2 into r sine theta. So replace the r with 3 sine theta plus theta times sine. And if you plug in pi over 2, you get 3 plus pi over 2. And if you plug in pi over 2 into 3 sine theta plus theta times cosine, you get a 0 out of the whole thing. Okay, and you would just essentially plug those things in, and this is your equation here at the end. And there you go. And just for a visual representation, this is the graph of 3 sine theta plus theta from 0 to 12 pi here, I believe. Anyways, here at pi over 2, you'd be looking at right here, and you're looking for the equation of the tangent line would roughly look something like that here, okay? Sorry about the arrow there. And there you go, that would be your equation. So that's visually what's going on, okay? All right, well, I hope this helps. Thank you for your time.